Algebra 2. This is Unit 10, Lesson 7, and today we're going to be multiplying and dividing rational expressions. So the rules are almost the same. Dividing is a little bit different if you remember back from algebra. But when I'm multiplying, the first thing you want to do is factor. So we're going to do lots of factoring here, and you have to be good at it, which is why we practiced it earlier. Then you want to cancel out any common factors. So you can cancel out anything that's in common. You can even cross-cancel, meaning the top of one fraction and the bottom of another fraction. And then you're just going to multiply the numerators and the denominators, and then you do have to check if you can simplify at the end. So let's try a few. We'll just try some monomials first, so those are a little bit easier. If you see the numbers like 5 and 10, 5 goes into 5 once, 5 goes into 10 twice. And then 8 and 6 are both divisible by 2. So 2 goes into 6 3 times, 2 goes into 8 4 times. And now I'm going to look at the variables that are there. I have x squared on the top and I have x cubed on the bottom. So the x squared on top is going to cancel with 2 of the x's on the bottom, but I'll still be left with an x. And then I have y to the third on the bottom. That's going to cancel with 3 of the y's on top, but I'll still have y to the fourth on top. All right, and then I just multiply everything that's left. 4 times 2 is 8. So I have 8y to the fourth on top. And on the bottom, I just have 3x. And then you just check, is there anything more I can cancel that I missed? Nope, that's my answer. All right, so that's a monomial. Let's try another, some monomials. So looking at B, look at I have 9r on the bottom. And I have 9r cubed on top. So the 9r on the bottom will cancel with the 9r cubed, but I'm still left with r squared because there was only one r on the bottom and there was 3 r's on top. The 4 and the 10 are both divisible by 2. So 2 goes into 4 twice and 2 goes into 10 5 times. The 2 p's on the bottom will cancel with 2 of the p's on top, but I'm still left with p squared. And the 1 q on top will cancel with 1 of the q's on the bottom, but again, I'm still left with q. So everything that's left on top is 2p squared r squared, and everything that's left on the bottom is just 5q. And again, just double check, nothing else that's left that I can simplify, and there's not. All right, it's going to get a little bit trickier when I have trinomials or binomials to factor. So a squared minus 5a plus 6 is a trinomial. Okay, it is factorable. I'm thinking of the factors of 6 that also add up to -5. So 6 and 5 is a tricky one because sometimes the factors are 6 and 1 and sometimes they're 2 and 3. It really depends on the sign. So if I want the numbers to multiply to 6 and add up to -5, that's going to be -2 and -3. Now, once I factor it, I'm going to put a line through it because I'm no longer using that trinomial. I'm just using the factors. On the top right, I can factor out a GCF. I'm going to pull out a 3, and I'm left with x plus 4. And both of the denominators cannot be factored. They're just binomial expressions. All right, I'm going to grab a different color so I can cancel out in another color. So look on the bottom, I have a plus 4. On the top, I have a plus 4. They cancel. On the bottom, I have a minus 2. That cancels with the a minus 2 on top. All right, so what am I left with? On top, I'm left with the 3, and I'm also left with the a minus 3. And I can just leave it like that. Well, actually, I probably don't want to leave it like that. Let me distribute that, and it's 3a minus 9. Okay, let's try another one with some trinomials and binomials. So top left has a GCF of x, and I'm left with x plus 3. Top right is a trinomial, so I'm going to factor it. I'm thinking of the factors of 4 that will give me a -5. Well, 4 times 1 is 4, and that can give me a -5 if it's -4 and -1. I got another trinomial on the bottom right. Again, the factors of 4, 4 and 1, but this time I want them to give me a -3 in the middle. And they will if the signs are different, if it's a -4 and a +1. And then x squared plus 2x minus 3. So you see, you really have to be proficient with factoring in all of these. The factors of 3 are just 3 and 1. I want them to give me a +2, so that's going to be a +3 and a -1. All right, now that everything's factored nicely, let's cancel out anything in common. So I have x minus 1 on the bottom, x minus 1 on top. X minus 4 on the bottom, x minus 4 on top. X plus 3 on top, x plus 3 on the bottom. What's left? I got this x on top, and I have this x plus 1 on the bottom. So the x stays on top, x plus 1 stays on the bottom. You cannot cancel those x's because that denominator is a binomial. That 1 is sort of attached to it. Okay, you cannot cancel it. That's my answer. All right, and then we're just going to try some dividing ones. So dividing is almost the very same thing, except you have to change to a multiplication problem first. The way I do that is I change to multiplication and you flip the second rational expression. So that second fraction gets flipped and you change it to multiplication. And then you're just doing the same exact thing. I'm factoring if possible. Cancel out any common factors. Don't forget you can cross cancel. You multiply any numerators or denominators, and then you simplify if there's any more simplifying to do. All right, so let's look at the problems that we have. I have 15x squared over 6y to the fifth, so that's staying the same. I change to multiplication, and I flip that second fraction. So the 2y to the seventh goes on top, and the 5x to the eighth goes on the bottom. Now I can cancel. All right, so 5 goes into 5 once, 5 goes into 15 3 times. 2 goes into 2 once, 2 goes into 6 3 times. The x squared on top cancels with 2 of the x's on the bottom, but I'm still left with x to the 6. And the 5y's on the bottom cancel with 5 of the y's on top, but I'm still left with 2 y's. All right, everything that's left... actually, there's one more thing. See how I have a 3 on top and a 3 on the bottom? Those can get canceled out. So on top, I just have y squared, and on the bottom, I just have x to the 6. Right? If you didn't recognize the 3's, once you wrote them, you would have seen it in your answer, and that's why we always say simplify if possible at the end. All right, I'm going to try another monomial. So the first fraction stays the same. Second one, I change to multiplication and I flip it. So 8x goes to the top, 24y squared goes to the bottom. Now I'm going to cancel anything I can. So let's see what I got. 8, I'm going to cancel this way. 8 goes into 24 3 times. And then look at the 30 and the 20. The zeros cancel. All right, so then I'm actually just going to be left with 3 and 2. And then I have a 3 on the bottom and a 3 on top, so those also cancel. So I took care of all the numbers. The x on top cancels with 2 of the x's on the bottom, but I'll still be left with x squared. And the y squared on the bottom cancels with 2 of the y's on top, but I'm still left with y to the 4th. So what's left on top? Y to the 4th. What's left on the bottom? It's going to be 2x squared. I'm just looking at my answers because for some reason I lost the 2, but that 2 didn't go anywhere. So there we go. Okay. All right. Definitely gets complicated when I have trinomials and binomials and GCFs to do. So what I generally do is when I'm rewriting it, okay, I'm going to factor it as I rewrite it. So the fraction stays, but I'm going to rewrite it in its factored form. So I'm looking for the factors of 8 that give me a 2. Well, that's just going to be 4 times 2. And then in order to give me a positive 2, it's a positive 4 and a negative 2. 8x minus 16. We'll pull out a GCF of 8, and I'm left with x minus 2. Now I'm changing to multiplication, and I'm going to flip these. As I'm flipping them, I'm going to factor them. So the 2x plus 10 is at the top, but I'm going to pull out a GCF of 2. The x squared minus 16 is on the bottom, but again, that's the difference of 2 perfect squares, and I'm just going to factor it. If you needed to write it first and then factor it, that's certainly fine to do. But I'm factoring it as I'm flipping it. And then I'm just going to cancel out x minus 2, x minus 2. X plus 4, x plus 4. And 2 goes into 8 4 times. So I'm left with x plus 5 on top. And on bottom, I'm left with 4 and x minus 4. And I'll just clean that up a little bit. And I'll be left with 4x minus 16. Okay? Try another one. So 9x squared minus 1. Are you guys recognizing that? That's just the difference of two perfect squares. It's 3x plus 1 and 3x minus 1. And then 3x squared plus 7x plus 2. I'm going to factor that. Now, you guys probably do the AC method, so you might want to do that off to the side. You can certainly do that. I can just do it by sort of guessing and checking. So, because this one's actually pretty easy. 3x times x is 3x squared. The only factors are 2 and 1. The 2 has to go here because that number that goes here is technically multiplied by that 3. And then the 1 goes here. So I technically have 6x and 1x. That's how I'm getting that 7x in the middle. If you want to do the AC method, you certainly can. Now remember, I'm changing to multiplication. I'm flipping this so that trinomial is now on the top. And I'm factoring it. The factors of 14, that will give me a negative 5. Well, if it's negative 7 and plus 2, that multiplies to negative 14. And it also combines together to give me negative 5. And then 5, I'm going to pull out a 5 from here, and I'm left with 1 minus 3x. All right. So this one's going to be a little bit trickier to seeing what's in common. I mean, the x plus 2 and the x plus 2, that's pretty easy. The 3x plus 1 and the 3x plus 1, that's pretty easy. But I don't know if you guys can recognize that we talked about this before in an earlier unit. These are essentially the same. The problem is the sign is off. But I can cancel this on the bottom with this on top. But since the signs are off, I'm left with a negative 1. All right, so basically you have a negative 1 on top, and you have x minus 7 on top, and I have a 5 on the bottom. And I can just distribute that negative 1 that's on top. And that would be my answer. So that was a little bit trickier, the canceling part. And then I just have one last problem that's a multiple choice. So I'm dividing, so the first fraction stays the same, just the difference of two perfect squares. And the bottom is a monomial. The second fraction I'm dividing, I'm going to change to multiplication. The 9x will go to the top because I have to flip that fraction, and the x plus 5 goes to the bottom. Let's cancel everything we can. X plus 5 and x plus 5 cancel. The 3x cancels with the 9x, but I am left with 3. So that means I'm left with 3 parentheses x minus 5, and that is just 3x minus 15. So that is choice 2. Okay, so this is going to, it's certainly going to need some practicing, and we'll practice that together tomorrow in class.